Hello everyone, this is Jinju Wang. In last session, we clipped out this rectangle from the whole original rectangle using its column and the row indexes. And in this part of session 3, we will do the same but using a different technique. Let's look at this picture. We know the top left corner has the coordinate of 100 million and 43 million something, and we know the bottom right has the coordinates of 100 million and 43 million. So basically, the idea is we tell Ludo that we want cells that is greater than 100 million to 100 million, and the rows are 400 million to 400 million. The essence is we will use the real world coordinate to slicing down the array rather than using the column and row indexes. Let's go back to VS Code, save all the files we have used before, and in this Explorer tab, let's create a new Python slice image with chords.py. Okay, to slicing down the image with its real-world coordination, we need to use xArray as xr, and as we can see here, the xArray is not installed yet. So I will use countdown to install it. Because we have shown this in many times, I believe you have already learned how to install the package. So I will show as the last time to illustrate how to install packages. First thing first, we need to countdown activate GeoEnv first. Let's get inside the GeoEnv and countdown env list. If we can see there's a little asterisk below the GeoEnv, that means we are inside this environment. And then we will countdown install xArray. And then wait for a second and hit enter if it prompts to ask us for installing additional packages. Just press enter. And I will recording after the installation of this. Also, we need import real xArray, which is raster built upon xArray. You can think of it as xr. And real xArray is not installed yet. We will install it too. Okay, now everything is successfully installed. And let's run these two lines of code. So we import xArray and real xArray. First, read raster with real xArray. And the good thing is we don't need to use the with statement to open raster files using real xArray. We just need to raster datasets equals rxr.open rasterio, and we can give it a argument chunks equals true. Let's run that. Okay, yeah, we need to copy the file path first. Copy relative file path and paste it there. Okay, run it. No module named Dask. Okay, same story. We need to install Dask. I will start a recording after finishing installing this. Alright, we have installed Dask. Now let's run this line of code. Now we get this error says Dask should be, the version of Dask should be greater than 0.18. So let's, in the installation command, let's just copy this version 0. This and that 0.18.0 and rerun the installation code. Okay, I failed to install Dask with the higher version, but it's okay. Let's just remove the chunks equals auto, remove this argument and rerun this code. So now we get the raster datasets. it tells us the dataset is 3 bands with 92 Ys and 156 X's. Okay, now let's go to the QGIS. Our job is to clip out this part of the data. So let's click here using this finding tool. Probably need to move it down. So we can see the X is this many value. Unluckily, this number cannot be copied, so I manually typed them in there. Basically, that's the starting and ending point of X, Y, the real world coordinates. Now, we can slice the raster dataset using real world coordinates. So the command is this. Slice the raster equals raster datasets we just read in, and X equals this, and Y equals this. Let's run this line and see what we got. We got nothing. Y from Y2. Should be Y from Y2. Now let's rerun the code and see the function. What we got is we got 3 bands. The Y is with a length of 18 and the X with a length of 34. Let's plot the first band. We can use this. We can still using the old slicing way, and it's very convenient to just have a plot. So we can see this is the sliced data. Now to check if we get everything right, we will save the sliced data to new file. And here is you can see the beauty of using raster, using RILE-XArray. With the sliced data, we just use its RILE to raster command, and we just give it a name, sliced solar panel here using chord, Latif, and then magically this data is saved to disk. Let's pull out this data from the data here, this one. Let's make it here. Okay, how good is that? I could say this is very simple command and helped us a lot. See, we sliced the correct data. Okay, this is the part 3 of Fetching 3. In this part, we use RILE-XArray to read raster data and slice the data using its real-world XY coordinate. These coordinates can be longitude and latitude as well. The technique is the same. We can see that using this package make things much easier and make the code using less code to achieve the same function. However, in many cases, we still need to understand this manual way, because using this package, it automatically has processed a lot of data and information behind the hood. And in many real-world cases, we need to manually control what's going on behind the slicing and the processing.